right, so we're going to get started. So we're going to show you how ROCK is transforming not only Alta surveys, but also, floodplain management, public improvement projects, right-of-way acquisitions, master plans, all that kind of stuff you're doing. And what you're going to see is a complete A to Z workflow, faster, safer, more efficient, more accurate than traditional methods. We'll start with the whole workflow. So we'll take you through the data acquisition and, how drone LiDAR data combined with RTK ground control points enables you to have quick and safe, collection of millions of survey-grade data points. We'll talk about the data processing. So using ROCK Desktop to create the 3D point cloud and the ortho mosaic, and how ROCK Cloud makes it very easy to visualize and share and align the data. You can also correct your local coordinate system and projections to make sure it's all in that, projection that you need it in. Show you, here we go, Vince is coming in. Get him in the call, and then we'll show you how we produce the CAD deliverables. So everything, how ROCK Pro Services extracts all the planimetrics, all the CAD features, everything you need for delivering those files ready for immediate use, into software like Civil 3D. So each step of the way, we'll compare the whole process. We'll show you the whole traditional methods. We'll show you, talk about total stations, RTK. What if you're out in the field and you're hacking trees down or blackberry bushes, and how crazy that is. You know how that goes. That whole thing about drone and mobile and SLAM LiDAR data capture to make it much more efficient, and gives you significant advantages over speed, safety, and the data you're collecting. So everyone's coming in the call now. All right. Okay. They're just a bit busy. So we'll talk you through a whole world example. We did a great project. Andrew and the team went out in Denver, the 56th Street underpass, and that whole data set includes everything you want from the whole flight trajectory, the whole process 3D data, the ortho mosaics, the CAD deliverables. So by the end of this meeting, you'll have a whole understanding of how ROCK can help you achieve that level of result with less effort on your side. We are an extension of your team. So we'll just jump into the whole overview now, and as we kind of go around, everyone will sort of talk there little bits and show you how that was acquired. So the whole A to Z workflow, how do we do it from start to finish? Well, we acquired the data. So using the whole drone LiDAR, we planned and we executed the mission for the 56th Street under or overpass, whichever you want to call it. We collected millions of points, all the detailed features like the curbs, the parking lot lines, the building footprints. We used ground control points, and we captured them with the RTK to ensure the precise alignment with the whole coordinate system and all that projection. So the whole benefit for you guys is faster data collection, reduced on-site risks, and a comprehensive coverage even under the tree canopies and even under the bridge underpass, which you'll see as well. We'll show you guys how we process the data. So the raw data was processed in ROCK Desktop. We created a high-resolution 3D point cloud and an ortho mosaic, and we uploaded that to the ROCK Cloud, and everything was aligned with all the GCPs and visualized in a very user-friendly platform. The benefits of that is, we are masters at the 3D computing. So all the tech behind it to visualize the point clouds, to have that whole suite of tools to make them all useful, and also share that with your clients and your customers, and your colleagues, if you want to pass the data set around, and also kind of how we're doing it right now. You're seeing the data set as we're having it up and running. So the benefits of that: simplified processing, instant visualization, and a seamless collaboration with your team and your clients. And then we'll take you into the whole, CAD deliverables and how we use ROCK Pro Services. We extracted all the necessary CAD files, all the planimetric stuff. Everything from the parking lot layouts, the curb, building footprints are all delivered in Civil 3D compatible formats, ready for immediate ingestion. And so what that does, it basically saves you guys, time. Like let us do the processing for you. All the CAD extractions, we've done this millions of times. Our team, does all that work for you and gets you those deliverables faster. Then you can just pull them off the project. So we'll show you that whole workflow, and then we'll see the whole data set come to life as we go through it. So with that being said, we'll just kind of jump into it. I'll pass it off to Andrew, who'll talk about the first part of the missions and the acquisitions.
Sure. Thanks, Dan. So welcome to our AMA today. And as Dan discussed, we're going to be getting into effectively planning and preparing for a LiDAR survey project that's going to combine your SLAM and airborne LiDAR data. So whether you're a seasoned professional or you're just getting started, we really hope that these guidelines are helpful to you and your team. And let's dive in. Just want to point out, while we are going through this, if you have any questions, please use our chat. We have people who are keeping an eye on that. And if it's a question that they can quickly answer, they will. If it's something they feel should be brought to the attention of everyone, we will get notified of it, and then I'll address it, or whoever is speaking at that time will do their best to address it. So the first thing we want to start talking about, and really kind of getting into the detailed steps, is setting the stage. So many projects that you or your colleagues may work on are going to require data capture from both the air or a ground-based LiDAR system. This could be due to environments with GNSS denial, such as, in this project, an underpass, tunnels, dense urban canyons, where traditional LiDAR via an airborne method can't directly capture the detail beneath structures. So in doing so, we always want to, at the start, we want to take the time to understand the survey area, timeline, as well as the goals of the project, and use that to inform planning and how our data is going to be captured. So, when your final deliverables are going to likely be delivered through combining airborne LiDAR and SLAM data, it's going to be, we're using that SLAM in the GNSS denied environments, or where traditional airborne methods aren't going to work. And for the site that we're looking at, this is approximately 40 acres. And so just to keep things in mind for a site like this with traditional methods, that could take a crew of multiple people being on site for a day or more. So I will get into the details of how long data collection actually took, but let's just keep that in mind, that for using traditional methods for a site like this with the complexity of this area, it's a multi-day process just to collect the data. So as we talk about that, now we want to move into our SLAM data set, and we're going to talk about defining the survey area. And so in this case, we want to focus on the area where we're going to be collecting the SLAM data. And in this example, where we have an overpass, that's going to be our GNSS denied environment. And you first want to define the extent of the area that requires this fine detail. So the way we want to think of it is not a straight vertical drop from the edge of that overpass on 56th coming straight down, because with the SLAM, while that's where GNSS denial would start, and we're not going to be able to see through that, we would have reduced GNSS quality for SLAM capture towards the edges of it. So we want to take that into account, use that to define our area. So we want to identify the GNSS denied zones and determine where we can't rely on that GNSS signal, and then use that to establish our coverage limits. So how far we need to map beneath the structure and into the or enclosed space. In this case, what you can see in our area where we start to overlap, we went to what you see right now, that junction of the walking paths. We went out to about there. So we went we probably went about 50 feet beyond where we were in the truly GNSS denied environment. And on the other side, probably a similar amount. So the next thing I would recommend is planning your path. Please take the time to consider how you will traverse the area with the SLAM device so that you can capture all the critical features. Now, this often means starting in an area and also ending in an area with strong geometric references. This is going to be walls, columns, or pillars to help the SLAM algorithm lock in accurately. So my recommendation is, just because traditional methods with a total station for surveying an area like this is pretty time consuming. However, the SLAM capture for this underpass only took 5 minutes. But what I found, and what I found for my data capture approach with SLAM, is that I like to get on site and just take out the SLAM dock and the SLAM rod. I set that up and I do a testing walk path of the area that we're going to survey. And the whole purpose of this is just so I can get fully acquainted with the area, and also I can be keeping an eye out and refining things like, what is my path? Where do I want to focus on loop closure? Where are those strong geometric features that I really want to make sure get good coverage? And where are areas of essentially poor features that I want to try and avoid or not spend too much time near? As you can see, off to the moving to the north of that path junction, it's a pretty large open field. And in areas like that, SLAM just has reduced capabilities because there's a lack of features. And that was one of the things we determined on site before we even started capturing our SLAM data. So now, as we move into the actual data capture with SLAM, as I said, we want those geometric features and geometric complexity to be included in the capture. So this is going to be edges like we have on the retaining wall right here, where it goes from a vertical face off to an angled face, the concrete pillars that you can see. These concrete pillars and retaining walls are present on both sides of the underpass, which was very helpful. So that is going to be necessary. We want to make sure that we're focused on loop closure. Loop closure is going to be, returning your sensor to a previously mapped area, enabling the software to reduce drift and improve the overall accuracy. What I learned and what I had to understand with my approach was that it's loop closure, not loop twirling. So just making a small circle that's 4 to 5 feet in diameter is not going to be sufficient. As you can see with this area, we traversed down one side of the underpass, looped around, came back on the other side of the underpass, and returned to where we started. That was closing the loop for us. And then as I got into earlier, areas to avoid. So the further away we move from the underpass, the less features were present, which can make SLAM processing difficult. So we minimize the time collecting data in those areas. Now, moving into the airborne mission planning considerations. We want to determine if terrain following is needed for the survey area due to the topographic variation that may be present. In this area, there was topographic variation that was present. It wasn't all that much on the order where it was determined terrain following was needed. But what we did do is we reduced the flight height of the drone so that if we had, because we took off around the midpoint of the survey area, so just to make sure in the areas of lower topography, the drone wasn't going to be too far off the surface and cause reduced data accuracy. Then we focused on our mission parameters based upon the goals. So for a survey grade deliverables like we were interested in for this project, we recommend flying at 45 meters altitude, 4 to 5 meters per second with 50% overlap. As I mentioned, we reduced that altitude to 37 for this specific area, just due to the topographic variation that was present and to kind of play it safe. GCP alignment is also going to be critical. We want to make sure that we can properly distribute the GCPs throughout the survey area. When I was learning about GCP placement for drone surveying, I was taught the analogy of a tablecloth on a table outside on a windy day. If you're using rocks to hold down that tablecloth, just one in the center is still going to cause that tablecloth to get moved by wind. But if you take those rocks and you put one in the center and multiple around the edges, it's going to help reduce that movement. So that's the analogy I like to think of with GCP placement. And then also any safety or airspace restrictions. It is the pilot's responsibility in the United States to ensure that they know of any flight restrictions, airspace restrictions, or altitude restrictions for their survey area. And then also understanding what sort of safety parameters might be in place, whether it's utility lines nearby, people being on site, so on and so forth. And those can be made when you're arriving on site. So now I'm going to get into the actual ground control placement for this site, just because with merging of airborne and SLAM, it really had to be taken into account. We wanted to make sure that at the end, our SLAM data could align with our airborne data. And so for that, proper GCP placement for tie-in using the common coordinate reference system was paramount. So first off, as I mentioned, even distribution, we wanted GCPs placed throughout the entire project area. So if you were to look at our entire survey area from a whole, you will see that we did have ground control points. They weren't used in processing, but they were placed throughout the entire survey area. We had them there just if needed. However, we also wanted to do higher coverage of the GCPs in the areas of the airborne and SLAM overpass overlap. So as you can see, there are 6 GCPs down in that area. These are going to be the GCPs that we want to collect both in the airborne survey as well in the SLAM survey. So we had 6 that were present for both airborne and SLAM. And then accurate surveying. So each GCP should be surveyed in correctly using a GNSS rod and antenna. And so with that, please keep in mind that nearby obstructions can reduce the accuracy of that surveyed GCP location. So we had to move away from the overpass to ensure that wasn't going to be an issue. We always like to think it's a bit of an accuracy in, accuracy out. So your final accuracy, if you're aligning to GCPs, is only going to be as good as the confidence and the accuracy of the GCPs that you survey in. So if they have a higher RMS error, then it's likely that you might see decreased accuracy in the final results. Excuse me. So right now, some details for this area. As I mentioned, the SLAM data capture took roughly 5 minutes. However, I incorporated some testing on this site because with an underpass, there is a painting method that needs to be done. The scan for the SLAM is kind of going out from the unit. If you can imagine it spinning like this, the SLAM, the lasers are shooting out that way. So for the areas of the underpass directly on top of it, you're not going to see that. So you have to do a bit of a painting method. So we took the opportunity for this site to do 3 different approaches for that painting method to see which one gave us the best results. Again, that's another recommendation with SLAM. The amount of time that you can save versus traditional methods, it's probably going to be worth it for multiple collections, just to ensure if you do have to do painting, you are getting the final data set that you want and fits the project goals. So now moving on to the airborne data set for capture. This was a 25-minute flight. And if you look at our trajectory, you can also see that during this, we not only captured flight lines that were perpendicular to the road, but at the end of the flight, we went in and got some coverage that was parallel to the underpass area to increase our data coverage in the area that we knew we would be overlapping with the SLAM. So now moving on to integrating and yes, I said 25 minutes. Sorry, I'm forgetting what I said already. So moving on to integrating the airborne and the SLAM data. Once everything has been captured, we're going to move to the processing stage. And the end goal is to be able to integrate these data sets seamlessly. So for that, for the airborne data processing, after collecting the data set and processing in ROCK Desktop, the airborne data is going to be aligned using the GCPs in the ROCK Cloud software. Now, for SLAM, when you do the alignment to the GCPs in SLAM, that is done in ROCK Desktop in the process trajectory or step 3 phase. So that is done. Once you have both your airborne and SLAM data sets processed and aligned and uploaded to the ROCK Cloud, then you can move into merging them in ROCK Cloud, which is what we're showing right here. You also have the ability with your merged data sets to compare them, and that's what we did after they had been uploaded. You're able to check for the overlap and consistency between your SLAM data and your airborne data in ROCK Cloud. Essentially, what you're looking for is that they line up like this. They're coming in at exactly the same surface as opposed to having offsets. So by following the steps above, both your airborne and SLAM data sets, they're going to be referenced to the same GCP network. And that's going to ensure that after processing and overlaying those 2 data sets, they are going to be accurately merged together. So just to go over the final points and review them, proper planning before data collection is crucial. Please understand your survey area and focus on making your decisions based upon the final project goals. You want to ensure that there are sufficient geometric features and loop closure when collecting your SLAM data. Distribute your GCPs wisely for both airborne and SLAM surveys. As I mentioned, we had 6 GCPs that were surveyed in the overlapping area between the airborne and SLAM data. And finally, survey your GCPs in accurately. Accuracy in is going to lead to accuracy out.
Awesome. That is some amazing tidbits of knowledge from Andrew's data acquisition and collection mission plan. I hope you guys all kind of, got something. And the whole thing about the, GCPs and the tablecloth analogy, a world of knowledge. So that's good stuff for that. So if you guys have any questions on that, by all means, please write them in the chat. We'll move on to our second part of the whole process for the data processing, and we'll let Jamie take it away.
Hi. Ren had a question. With the roadway over the walking path, how does the surface generate or import into Civil 3D? We will get there. But there's ways to export it, and I will go over all of that. So Andrew's now driving, and basically once your project is aligned to your satisfaction, you are now ready to unlock the insights, the knowledge, and the power of ROCK Pro Services. Our team delivers CAD-ready deliverables, surface models, and contours, enabling actionable insights for your clients. Simply upload your acres to your account, initiate processing, and ROCK Pro Services seamlessly becomes an extension of your team. From there, we pick up the data provided and begin processing pretty much right away. And if there's any non-standard classifications needed or specific features marked in a certain way, we can please leave annotations with our annotation tool, or feel free to mark areas in the measurements toolbar for enhanced processing. Like brake lines would be annotated with the measurement tool. And then there's also an additional notes section on the ordering page to include high-level details, ensuring that everyone is aligned to get you the best data faster. And then in this case, we processed, oh, thank you. Yes, show people the ordering page. It actually, if you go back to the project and you go down and hit, if you go to hit ROCK Surveyor, you can see it and hit order. Yeah, there's that notes page I'm talking about. It's that big white box underneath the order summary. And those kind of notes stay with the project from beginning to end, so that every single person who touches the project has access to those notes and can see them. It's really helpful, and it makes, if there's any high level details, they can be annotated and, marked. In this case, we processed this project with both ROCK Surveyor and ROCK Planet Metrics. So I'm going to start talking about the power of the ROCK AI algorithms. Every ROCK Surveyor project is analyzed by our advanced ROCK AI to determine ground points. Our algorithm continuously learns and improves, enabling it to differentiate between ground and non-ground with increasing precision. ROCK AI identifies the most accurate middle points in the ground surface, avoiding errors caused by low points, such as like the bottom of grates or tall grass that could distort your surface model. From there, once it's kind of run through the ROCK AI, that's when we get to the data quality assessment. At ROCK, we've really seen it all, processing thousands and thousands of data sets. Every data set undergoes thorough quality control by our expert team. Leveraging insights from the hundreds of thousands of mentioned data sets, we ensure the highest quality results. If adjustments are needed, we provide customized reports to address any concerns. Currently, we have a 12-point data quality assessment that each project goes through, hitting the most frequent pain points we often see in data quality, from colorization accuracy to point cloud density beneath vegetation, as well as horizontal and vertical alignment of GCPs to the point cloud. The takeaways you receive from the data quality assessment are invaluable. You can use the data quality assessment to identify pilot areas for improvement, making each data collection better than the last with the power of ROCK Pro Services. In this case, we had Andrew, our resident and one of our expert pilots, taking this, so no issues with that. Flying colors on the data quality assessment in this case. And now this is kind of getting closer to Ren, what you were asking about. Precision CAD deliverables by ROCK Pro Services are designed for civil engineers and surveyors. With ROCK Pro Services, you get more than just line work. You gain high accuracy, survey-grade CAD deliverables that seamlessly integrate into Civil 3D or other CAD software workflows. Leveraging industry expertise in LiDAR, orthomosaic imagery, and point cloud processing, we transform raw data into precise, engineering-ready files that meet and exceed project standards. ROCK Pro Services makes it simple to access and manage your project data directly through the ROCK Cloud. From there, you can monitor project progress, export deliverables, which is exactly what you were asking about, Ren, in your preferred desktop software, in your preferred file type. Andrew, if you could just go over, it's down below the process button. It's that little export button, and you can export a bunch of different file types. You know, whatever you need, whatever your customer needs, we have a bunch of different files that, you know, so you're not bogged down by all the different file types in the deliverables menu. But that's the kind of thing that you might have been asking about. This streamlined delivery ensures that your team stays connected and that your clients can easily access the information they need. You can choose client level of access from just the deliverables to the initial raw files as necessary. The deliverables you receive are precise, dependable, and tailored to your needs. ROCK provides expertly vectorized features such as curb and gutter line work, curb ramps, which I know we were talking about, you were talking about ADA ramps earlier, utility symbols, survey benchmarks, and even stormwater and drainage infrastructure. Material changes are also denoted, like the end of an asphalt, where the concrete ends, and such. All are captured with precision. Every deliverable is meticulously drawn to integrate seamlessly with industry standard software like Civil 3D or Trimble Business Center. Whether you're working with line work, control points, or detailed infrastructure representations, ROCK ensures that all features align with your project specific requirements. Professionals can trust every layer, point, and line to provide an accurate, reliable representation of site conditions, empowering them to deliver exceptional results. And I really do want to, you know, applaud the team's work on this. I know the underpass structure that Andrew is kind of showing the line work on right now is particularly detailed, especially if you, Andrew, could you tilt it so it's like you could see versus like a head down view? Yeah. So we were able to get like all the points along the walls and all the bulkhead and everything underneath the concrete structures. I found this to be really fascinating, and it definitely was a welcome workflow. We were, you know, it was like, how do we do this? How do we encapsulate it? And how do we make it represent the ultimate features so that not only does the line work represent what's going on, but does the surface model accurately represent the surface at every facet? Okay. Do you have a question, Emil, or are you good? Okay, make sure. But ROCK Pro Services provides a seamless end-to-end solution for processing and delivering high-quality geospatial data tailored to meet the needs of engineers, surveyors, and other professionals. Starting with your project submission, the team quickly processes your data, delivering CAD-ready outputs, surface models, and contours that empower actionable insights. The service becomes an extension of your team, enabling enhanced workflows through easy uploads, the ability to add annotations, and specific customization requests. Seriously, if you don't see it, just ask us. We'd love to be able to discuss with you, you know, how we can make what we're doing fit your needs all the better. ROCK AI algorithms will ensure precision by identifying accurate ground points, avoiding distortions caused by terrain anomalies. Each data set undergoes that 12-point quality assessment, and you're able to kind of get feedback, you know, make that next data set even better. The assessment not only guarantees superior deliverables, but also helps clients refine future data collection practices. And finally, ROCK Pro Services excels in delivering precise, survey-grade CAD outputs that integrate seamlessly with CAD software such as Civil 3D. These deliverables, from curb line work and utility symbols to drainage infrastructure, are meticulously drawn to meet industry standards or project-specific requirements. With simplified delivery through the ROCK Cloud, clients can export files directly or share projects for enhanced collaboration. Professionals can trust ROCK's deliverables for accurate, reliable representations of site conditions, enabling them to achieve exceptional project outcomes. Thank you, Andrew, for driving during this. There's just so many fun features on this data set, from the tennis courts, to the underpass, to the fields. It was such a, you know, treat to have so many different features in one data set. Yeah, I very much enjoyed how the line work on the tennis courts came out. Yeah, Ren, does that kind of get at what your question was about? How does the surface generate or import into Civil 3D? If I want, I can go into a little bit more detail now.
It was more of, you know, you have a great 3D representation. When you get the contours or the surface back, I know sometimes it wants to hold the road, on the very top is seeing that, and then other times it will want to map like the box culvert or the bottom of the ditch, and then it shows the road coming in and following the ditch as opposed to staying with the road. I know with like Civil 3D, it's tough to have two surfaces, one with a bridge and one with the swale below. That's if it's a box culvert, it's always easy because we can just show it as like hidden lines. I didn't know if there's something that's worked for you in the past in trying to get those deliverables.
I honestly will say, I mean, I know for a fact, okay, I thought your question was going to be more like, how do we get those into Civil 3D? But the biggest thing is you can export, whatever file type you need. I know land XML is one that gets in pretty seamlessly with Civil 3D. That is an exportable type. I also have known people to just take our contours and build the surface in Civil 3D from our contours. We also can generate a ply file type, which is, it's closer to a tin. It's just more open source, and that can help generate it as well. I know in this case, Andrew, can you turn on the surface over and show kind of how the surface model turns out on the underpass? So yeah, it's right in there. And this is kind of how our surface turned out. So we wanted to make sure that the road and where the overpass is, it cuts off at the appropriate point. So it's, not until the very, very edge does it kind of cut off, but it's a steep cutoff.
Correct.
Yeah.
Yep. And I've seen that. I mean, because I know, depending if we're sticking with a traffic planning department, they want to see the road surface or the bridge as opposed to the ground underneath, and that's always the difficult part. Typically, if it's something open like this, it'll show like you see it now. I think we had one that was a box culvert, and we got a lot of data, and it showed the road coming in and going straight down and back up the box culvert. So I wasn't sure the easiest way to. I guess what I could do is if I got a project like this, I can let you know what I would rather hold.
Yes, please.
Over another. If it's a box culvert, just say do the road surface. And as far as when you show the box culvert, all we're going to want are like inverts and the outside edges of the box. And then we can just show it as like a hidden line running underneath the roadway. I
understand now what you're asking for.
But most of them are like this. If it's a bridge or an overpass, you always want to show it the way you have it right here with, the ground elevation. And then the bridge is just like a superimposed line over top of it.
Yes.
Okay.
And we can, and that's totally, and that's kind of what, we'd love to be able to, if you just send us the note or put in the notes, like, hey, there's a box culvert, like retained surface, or, we care more about the underneath than the above. And that's the kind of notes that we'd love to have, because then we're not guessing, we're not doing back and forth. The notes are just there and then any team member working on it anytime can access those notes. And that's kind of been big and helpful, because then we're kind of, it's not a, hey, what does the customer want? It's, no, this is what they want.
Okay. All right. No, that sounds great.
You can use a number of methods to communicate that if you need to, right? So you can always put the notes in there, or, I don't know if you have to drill down into specific, tools and features of the ROCK Cloud, but we always like to say, if you want to do some annotations on specific areas of interest, we're happy to take those into consideration. It just, so the whole team can look at it and what's important, right? So that's a perfect example right there. Just simply draw an annotation on there, put it in there, put the name, the title, and we can really focus on that stuff. And it just the whole operation, right? Yeah.
All right. No, that sounds great.
Yeah. Yes, and you can upload any LAS file. Once it's in a LAS file format, we can take it and process it. I think we also can process other types, but LAS is preferred.
Okay.
LAS or LAS. So yeah.
Cool. Well, that's pretty much. I mean, that's the whole workflow from A to Z, with with Andrew talking about the characteristics of the data capture, both with Aerial and SLAM, and then Jamie talking about the processing and then some post services. So that's what we got for you guys. The whole idea is it's faster, safer, more efficient for you guys to deliver survey grade results. But yeah, we're here for you guys' questions. So again, this is like a free-for-all for you guys to chime in, ask us anything about this data set or anything you wanted to learn about the ROCK Cloud or how to do certain things or LiDAR or anything. We're here for that.
Oh yes, turn on the contours. I haven't honestly looked at them in a bit, but I always like looking at the kind of the low and medium contours. The fine ones can kind of obviously get so the fine ones do look good, and obviously those are really the important ones, but they can also be like overwhelming when there's so many fine contour lines. But
question for you. You mentioned about doing the Alta deliverables. How do they differ, or what's included or not included versus like a traditional order?
Ooh, that is a good question. Jared might be able to help me out a little bit more with that. We are working on that. So it is a collaborative process. It's a very ingrained process. So honestly, if you're willing to, I'd love to meet with you, or if you can write up things that you're looking for in your Alta process. I can answer, at length in a yes/no format. So please feel free to shoot me, specifically jamie.lackner@ROCK Robotic, or shoot it to support. So then between me and Jared, we could get it figured out. But Jared, if you have any input on that.
No, that'll work. Yeah, send us an email. We'll definitely be able to dive into that.
Yeah. Jared's been working with some other customers on that, and we've been tailoring it to them a lot. What you need, we want to be able to make.
Yeah, every job we get seems to be different. We get all the table A items, depending on what they want, how they want it, how much details needed on structures or other items on the property. I guess it just depends on what I need at the end to get it back to you, so you can maybe do a custom setup for me that way. That seems to be the direction. It would probably work out a lot better that way.
Okay. Awesome. No, happy to. Yeah, please. We'd love to take a look at it and see how we can support you in that regard, because that is what we want to work towards. That's what we want to be able to support.
Yeah.
Okay.
Trying to think other things. I don't know. Andrew, you were with being on site with this. I know something that we talked about. You talked about the number of GCPs we had. I feel like we also something we learned, and something that it's kind of a, you collect GCPs, but something that happens that I do with the data quality assessment, I will go in and very often, obviously in this case, Andrew and the rest of the team that collected the GCPs with best of intentions. But something I do as part of the data quality assessment, if I find there's a particularly erroneous GCP, and it happens to be one that either really shouldn't be a GCP, I cannot tell you how many I've seen on top of like raised manholes, on ledges, on things that really just aren't ground. And ultimately what we have to do is we have to turn that either into a checkpoint or disable it. And that's something that we do, and we provide that feedback like, hey, we disabled this GCP because it really wasn't on the ground. It was showing 3 feet off the ground, and your under a 10th accuracy total was showing almost 1.5 feet because of that one erroneous point. So that's the kind of thing we're looking for when we do that data quality assessment. It gives that peace of mind that like what you're recording and what you're giving us is really going to be accurate.
We had one that we had done, I think it was June, and we ran it through your process. There was an overpass over the main highway, and everything was so wooded and thick. So we put the target on the overpass.
And sometimes you got to do that. I totally understand. But yes, because that's not the ground, it's going to say it's 10, 15 feet off.
Yep.
And yeah, the data quality assessment's kind of been since later summer. So that, that definitely is something that's been a newer feature. I like it because it gives more eyes to the data set. Not only are we looking at it, we're looking at it when it comes to us before we kind of start to do that more advanced processing, and after, to make sure that it's consistent and that what you're getting is, the best data possible.
Okay.
Yeah, you were not the first person, nor will you be the last to put them out on a bridge. We have a couple customers that, despite constant reminders, they still do it, but obviously that might be the only place you can. And if you're trying to just align it horizontally, that's a great usage. You can also use the checkpoint feature, because that can help align it, but then it's not being used for your GCP accuracy assessment. That's like the very top part of the accuracy report.
Okay. Question for you. When you're doing your setup and you're getting ready to do your flight and you're using your GPS, are you using like an end trip, or are you tying into your own ROCK GPS network, or are you doing post-processing? What, for Andrew, like, how have you done these locally? What works best for you?
For drones specifically, or for?
Sure, yes.
Yeah, so I mean, keep in mind that you're going to have your drone and LiDAR are both going to have their own separate GNSS receivers. So for your drone, if you want to utilize RTK for that, by all means, go ahead and do it. You just want to make sure that you're going to be able to, connect to that source and be able to consistently remain in connection with it. For the LiDAR unit, it is it's post-processing in ROCK Desktop. So the GNSS receiver on the LiDAR unit, you don't need to worry about connecting it to anything. And then, whether your base is on site or if you're using something like a ROCK network location, that's all done post through ROCK Desktop.
Okay. Yeah, my traditional workflow is, to set up the RS3, turn it on, let it go, get the, 350 all hooked up, get the LiDAR on it, do the flight, let everything assume its own data. And sometimes it comes in within 3 feet or 15 feet of where it's supposed to. And then luckily with all the equipment we have, we'll shoot everything with the GPS. We'll go around sometimes twice, double shoot everything and take all the averages we can to get it real tight. Or if it's open enough, we'll even set up with the robot and shoot. And then we're, under 100th, for your control. And it really tightens things up a little bit better that way. But then what I'll do is I'll bring everything in. The surface will come in. I'll have my ground control points and I'll just do that shift later because I know it's close. So that's been my process.
And for us, it'll depend upon our site and how long we're going to be there. So, for example, this site, which was a bit of a shorter selection time, we were able to get in there and we connected to a nearby rock base that was far away. So we did have super high accuracy when it was shot in. And then for like rain following set that we presented last week, we were too far away from the base station to do that, so we just left that base on site for an extended, more than 2 hours to use for it. Sorry about that wall coming in. I didn't want to be scrambling around on my screen to try and take a message.
I think that's a great point there, Ben. I mean, that's just you're as much of an expert as everyone in the room as far as just getting your control going on and getting this tightest alignment as possible. So that's really good feedback as well.
Yeah, I'm a little eerie about trying to load it into the actual drone, the GPS, have everything auto corrected at the same time. Sometimes I feel just let it do its thing. The base is set. As long as that's not moving, everything is oriented to that. And then I can always shift it later because I've tried to set the base on an actual known point, but we're usually collecting the points at the same time. And I'm still going to end up adjusting it, whether it's tenths or feet. So I usually just let it do its own thing, let it sit. Then when we come back, we can post-process everything internally and really get it tight that way. That seems to have worked well for me. I haven't really had any hiccups. The only thing that I've had that came in weird for me is doing the slam, like around my house or something like that, where I tried to do something goofy, like walk too fast or tilt it too quickly or things like that, where you'll look at the house and walls and things will be superimposed. But that was me more, I don't know, say, trying to push the limits and see how quick or how well it would work instead of taking my time and doing it the right way.
Yeah, I would say in regards to that, slam capture is best to be done slowly and purposefully. You imagine you're walking with a walker or something like that. You want to very slow, deliberate movements.
Okay.
Cakewalk style, think about it like you're trying to, or, bring in like a gallon of uncapped sweet tea. That's how I think of it.
Okay.
Not that I've done a lot of SLAM. Andrew's probably more the expert, but that's what I think of when I see his movements.
Except in that analogy, the gallon of sweet tea is above your head. So if you do mess it up, you're getting pretty wet and sticky.
Okay. I think that was about all I had for now. The only other questions I might have would be looking at a ROCK base station or getting hooked into the network or something like that for future. I don't know if this is the right conversation right now, but maybe we can talk, next week or something briefly. Or I think I do have some of the brochures and things that we've talked about. Might have been with Dan, a few months ago. But as far as networking in this area, I looked at your map, and where I'm located is kind of right in the middle of a whole bunch that are in my outskirts. They're 10, 15 miles away. If I would put one in, it would kind of close that network. So I didn't know if that was something that somebody who's the best person to talk to on that.
We can talk about that now. We can just you can show them the ROCK network map. You've seen it. Why don't we just drill in that example? You can go into the rock stars. If you go there you go. You got it up and running. So we can, this is a map of, I think we've got like 200,000 these things sold worldwide.
Okay.
So this is a map of where you can find them. And if you have your own, you access your own, you're right with, but sort of 10, 15 miles, from the base station, and you can click on one of them. Yeah. And you can see, you can just pull up the Rhinex file. You can get all the stats above it. And so it's $40 a month for subscription to access them all, right? So you could be out in the field and pull them off. You can get your own. You can access your own whenever you want to. It's mounted on your building.
Yeah.
And that's pretty much it. I mean, they're awesome tools.
Okay.
Yeah.
Well, that's our office right there. It would be Emmaus. So it's like kind of right in the middle of all the ones that you were looking at. So we're like right there in the middle of the screen. It would kind of tie the rest of that network together.
Yeah, I would say, Ren, for where you are, you're probably too far away from any of these to use them, unless unless you're kind of up here in this part of Northampton County, or
right.
you're too far away from that station. Obviously, if you come down here, you got to be close enough to those. So I mean, actually, it's really surprising. I would actually say that the Lehigh Valley is kind of so devoid of ROCK bases. Yeah.
And we do a lot of work in Lehigh and Northampton County. So obviously there's two already in Northampton. If I could put one in the Emmaus area, between that one and the other two up there, you're, maybe at the 8 or 10 miles if you're right smack in the middle between them. So, in our area, there's another network. It's called KeyNet. I don't know if you've heard of it, but they are freaking expensive. So like $3,500 a year expensive.
Oh,
yeah. But they're the monopoly. So that's why I'd rather have my own equipment and do it this way rather than buy back into them. Because our GPS, we do have a base. We use Javad system, and we get really great accuracy with it. But sometimes setting the base up, on a job site is tricky.
Mm-hmm. Yes. I would also say too, this can just serve as kind of the backup as well, where you just have that set up at your office, hooked up to a power source, continually collecting data. And let's say you go out to the job site, and for one reason or another, you've got poor GNSS data from the base that you set up on site. Well, pull the data from your ROCK base and use that instead.
Mm-hmm. Okay. Yeah, and then you don't have to go refly it because you have a lower number of satellites.
It's a very good point. That's a good tech. It's a redundancy tech tip, right? You always got to back up, so you don't have to redo it.
I mean, you can always think of the CORS network and the CORS stations as that backup, but I hate to use the cliche, but you get what you pay for, and since you don't pay anything for CORS, there's no guarantee it's collecting from all the constellations. There's no guarantee that it wasn't down, things like that. So I just saw it come in. I'm really sorry. I hope I don't butcher your name. Frontina. You had a question. Go ahead.
Oh, it's Valentina, but basically, yeah.
All right. Sorry about that. So the radius of the ROCK base, we recommend it's about, if you're more than 10 miles away from it, you're going to have reduced accuracy.
Thank you.
Awesome. Well, guys, we're getting to the top of the hour. Just for timekeeping purposes, I think this has been a very awesome kind of, walkthrough A to Z, and also some amazing questions that have been brought up. We started talking about the workflow. Now we're talking about, bases as far as like, connecting to your data and everything, and trajectories and all that fun stuff. So this is it's been a very complete workthrough. I'm quite pleased with that. So if you guys any more questions, top of that, feel free to write in. You guys will all get a copy of this. So once it's done recording, I'll send it up by the end of the day. Yeah, and then we're doing this on sort of every Friday. I think next Friday, then we'll take a bit of the holidays are coming up, so maybe we'll see you guys in the next one as well.
Yeah. No, thank you guys for your time. It's been wonderful, and I'm really glad we were able to share this kind of the whole ROCK workflow, the ROCK ecosystem with you guys. It's been a pleasure.
Awesome. Thanks, everyone. Have a happy Friday. We'll talk to you all soon.
Thank you very much.
Thanks, everyone. Bye for now.